So hello guys, in today's video we will discuss about the JDK internal structure. So basically in Java what we do, we basically first create a .java class. For example, we have created a student class, so we will mark it as a student.java. And then after when we first we have to compile the program. So first we compile, and during the after the compilation it will create a .class file, and .class file basically holds the bytecode, but we know that a machine level language demands are different, not a bytecode. So after that what we do, we it will basically go for the JVM, and then inside the JVM there is class loader, method area, and execution. So before understanding this part, let's understand first what is JDK, what is the need of JDK, what is JRE, and what is JVM. So basically JDK refers to the Java Development Kit, and it internally basically it contains inside the JDK you can see that it contains JRE and JVM. And here JRE is a Java runtime environment that provides the Java class library. For example, inside the Java class there are many library and packages that we need to run our program. And then after JVM, basically JVM is a main part of the JDK. It through this Java language has become the platform independent. Okay, so first of all, what we do, we will understand JDK. So inside JDK, basically, as I told that inside it JRE Java class library and then some development tools that basically helps to a Java program to compile, debug, etc. And it is used to develop compile as we know. And after that JRE, basically inside the JRE there is some JVM parts and some that are very important to run the Java applications. Okay, and that is java.lang, java.util, and yeah, and basically inside the JVM it provides all the needed things that will help to run the Java programs. And then after JVM, Java Virtual Machine, inside Java Virtual Machine basically it converts the bytecode into a machine code. So these are the JDK, JVM, and JRE. And apart from it, here you can in the diagram here you can see that inside the JDK it contains JRE and JVM, and inside JRE there is some JVM. So before understanding it, let's jump into the JVM. I think you have understood what is JDK, what is JRE. So let's understand the internal part of the JVM, because Java has become the platform independence because of the JVM. So first of all, before first thing that first we have to install the JDK, then we have to add it in our file a class path. Then after we can use the Java, and inside JDK basically it maintains all the JRE and JVM related needs. Okay, so let's jump into the JVM internal architecture. So basically this is the internal architecture of the JVM. So in previous I told that first of all what we do, first of all our program .java we save the file by .java. Then after we compile the program, then it internally converts it into a .class file. .class file that contains bytecode, and this bytecode will go for the JVM. And after this what will happen, and after this basically after the class file, when it comes to the class loader, so inside the class loader, basically there is loading, linking, and initialization phase. And these are the three phases inside the class loader subsystem. So basically in loading, basically find the dot class loading file. First what it do, it just find the dot class file and load it. The main purpose of it's to load the class, and extension class it basically can load all the dot all the you can under all the package related thing whatever we have used import it, so it will load that bootstrap class loader. It basically loads all the static related things. And then after linking, so inside the linking it basically verifies the bytecode and prepares memory, which memory where should it should contains, and prepare resolve. As we know that initialization basically the main purpose of initialization to execute the static code, that will be static blocks or a static variables. Okay, and then after method then After the class loader subsystem, there is a method area. Inside this method area, basically it has divided in some parts. First is a method area, second is a heap area, third is a stack area, and fourth is a PC register, and five is a native stack method. So basically every part it contains a too much definition and works. Basically method area it basically holds all your static related things. So basically all static, for example, class metadata, static variables, method bytecode, it basically contains only a method area. So you can take it as a, all the static related things basically holds inside the method area. Then after heap area will come, basically inside the heap area it basically store object and instance variable. Whatever object we will create, it basically come under the heap area, and whatever objects that are the part of the object, so it will also holds memory into a heap area. Then after stack area will come, inside the stack area basically it basically holds the all method call stack. So all the method internally creates one stack, and every stack will manage all their, if it used the stack, or you can take it as a recursion, so it will basically maintain one stack. And then after all the thread, basically we will create multiple threads inside in Java program, so every thread create its own stack, and they manage their own memory. Okay, so for that we have to use volatile. We will understand in further. Then after PC register, basically in the method area, PC register holds some small value, so we can easily run all the program or a calculation. Native method stack, basically this method stack only or for the native method. Native methods are those methods that had basically wrote in the C or a C++ language. So C or C++ language means some programs in Java has written already written in C and C++ language. We don't have to write it. Okay, and after the method runtime data area, or you can see take it as a method area, it goes to the execution engine. After the after the loading, linking, and initializes all the static variables, and after dividing all the memory, static, object, and all like thread related memory, it comes to the execution engine. So basically inside the execution engine there is interpreter basically runs converts bytecode into a machine code by line, and there is one JIT compiler. So basically JIT compiler refers to a just in time compiler. So whatever we use in Java programming, and so all the fixed code, for example we create main method, and apart from it we write some static things, object and constructor. These are fixed things that we basically use in each and every class. So what JIT, what it will do, it will contains its machine code after converting first time its byte code into a machine code. So it internally holds all its machine code. So in each and every case it will not generate a machine code. Basically after converting first time, whenever we will use man method, so internally it will call that particular interpreted code. And the garbage collection, so basically garbage collection collects all the garbage objects, whatever what object are not in use. And then after method, native method interface, so as I told that native method basically always connects with the C or C++ previous code that have already written in Java, but with the help of C and C++. And native method area library, this basically holds all the library that are the parts of the C or C++. So I think we have understood the JVM internal part. So inside the JVM, as I told, after loading a .class file, it goes to the class loader subsystem. So inside it, basically three parts comes. First is a loading, linking, initialization. Inside the loading class, what it will do, it will first load all the import classes or packages. Then it will go for the linking. Inside the linking it will verify the bytecode what mistakes we have done, and then after initialize, basically inside the initialization it initializes static block. Then after it comes to the method area related thing, so it has many areas that is related to method area. So it's basically most of the work related to static area. Then after heap area related to object and instance object variable, and stack basically holds all the call stack of the methods or a recursion, and apart from it, it also holds the thread related memory. And then after PC register is directly connected to a a core, so it run fastly. And native method stack basically it connects with the C and C++ code. And interpreter it basically converts all the bytecode line by line into a machine code. Then git compiler, it's basically the main purpose it to manage all the boilerplate code, so we don't have to convert a bytecode into a machine code multiple times. So it first it converts and it will use again by again that. And then a garbage collection, it collects all the garbage objects. And native method interface that will help to work with the native methods. So I think we have done all the JDK, JVM, JRE structure. So apart from it, you should definitely understand that JDK is a is a large pool. Inside the JDK there is JRE and JVM, and JRE is also a mid large pool. Inside JRE we have to there is JVM, and this JVM makes the Java code platform independent. I think we have understood all the things. So yeah, thank you.